Okay, this is review for Math 1, and there's my pen. Make sure you remember, because we're going to have a quiz over this here pretty soon, you're going to have a review today, what the model for height looks like. So your height at whatever time you're putting in for t is your initial height plus your initial velocity times your time, minus 16 times time squared. Okay. So once again, height, initial height, initial velocity, T stands for time, and 16 is the feet per second that gravity pulls you down. So that's the effect of gravity. So let's say you're given an initial height of 10, and let's say you have something launched for 3 seconds. Well, if you wanted to figure out what your initial velocity was to write your height function, you plug in your initial height, then we want to know when your height is actually going to be 0. So instead of using h, we're going to put 0 in for your height. Okay, and it's not always going to be 0. It could be any given height. So we're trying to solve for our velocity. We plug in 3 for our time. This is where your biggest mistakes will be. Make sure you do 3 squared times 16, not 16 times 3 squared. Big difference. So 3 squared is 9, so I have 16 times 9, or you can just put these in your calculator and it does the work for you. So 16 times 3 to the second power. Oops. That'll give me 144. So I can write this as 3v, and this is just solving now. I can combine my 10 and negative 144, so I have 3v minus 134, add 134 to both sides, because I want to get v by itself. Divide by 3, so 134 divided by 3, and so our velocity is going to be 44.6 repeating feet per second. So you write your height function. Height equals your initial height plus your initial velocity times your time minus 16t squared. You're going to have to be able to do that for the quiz. Sure hope you can. Okay, let's see. Your next lesson was over the Golden Gate quadratics, so being able to use your table and your graph to great effect. So make sure you can put things in your y equals. Remember to be able to use your table. So let's say we put this in our y equals. So 10 plus 44.6. I'm going to use x this time, not x squared, minus 16x squared. Okay, I can look at a graph of this, and hey, my graph shows up weird. So if you want to reset that, hit zoom and then standard, so 6. Okay, so that's where you should always start from. So it looks like I should care about those 3 seconds, right? Because we were told that's when it is. So I need to go up higher. And I can look in my table. Well, hey, it looks like the highest it gets is about 40. So let's change our window settings from 0 to 3. And let's go up to 50 and see what that looks like. There we go. So remember to be able to use trace, and you can drag all the way along there. And you can also look at your table, and you can change your table settings by hitting second window. So we do want to start at 0, but if you want to see at more precise intervals, you can put 0.01, go by hundredths of a second, and you can see exactly where it is at almost any given time. It's pretty incredible. All right, that's what that whole second investigation was about. Now, the part that I wish that I was here for. So again, better be able to use technology to help you, because we haven't taught you all the algebraic tools to be able to do this. And this was with transformations. So you had a parent function, which was y equals x squared, and that looks like your upwards facing parabola, and upwards facing u. Okay, we had a bunch of different cases where if we, the first one was changing the value in front. Okay, the coefficient. So let's say we had y equals ax squared. If a is greater than 1, so it's a value that's bigger than 1, so it's 2, 3, or even 1.5. From our parent function, we're going to see that graph become skinnier. It's going to be stretched, okay? Now, let's say if a is less than 1 and greater than 0. We're going to see that become wider, okay? Because it's stretched. It's compressed towards the y-axis. Those are the two different types, okay? So now, let's say I have instead a value that's added or subtracted there as a constant. That's going to move our values for our parent graph up or down. So let's say we add c instead. So it's just x squared plus c. It goes up whatever that value is. If it was minus, it would just move down. Okay, so if we had x squared minus c, it would move down. Okay. The second one we had. Let's say we had y equals negative x squared. When you have a negative, it flips downward. Okay, other ones we have. And these are the ones that are harder to get when you're a freshman. So let's say we have y equals x squared plus ax. Okay, oddly, when it's positive, this moves our graph to the left. Okay, it'll make a little more sense algebraically speaking later on. But if we look at this, let's say I'm going to set that back to standard. And let's say I have x squared. And now I have x squared plus 2x. It's going to graph my original and graph my next one. Do you see how it moved to the left? Now, it looks like it moved it down, but it didn't. See how the y-intercept is still the same value? So if you add, it moves left. It's a shift left. So now, let's say we have y equals x squared minus, instead of ax, let's use bx, just to be more consistent. If we use bx and we subtract 2x instead, it'll graph your original right here, and it'll graph the next one, and it's moved to the right. And again, it looks like it moved down. It didn't. The y-intercept's still in the same place. The vertex moved down, but right now we're not worried about that. So if I have this, y equals x squared plus bx, it's going to move my original to the left. But let's say we have y equals x squared minus bx, it's going to move my original it moves right. Okay, if we put these together, so let's say I have y equals negative x squared plus 2. I know that it's going to move my original up, so that's going to move my original up, but this is going to make it flip, just like we talked about earlier. So it's going to be facing downward. Okay, let's say I have y equals x squared and then plus 2x plus 2. Well, this is going to move us to the left, and this is going to move us up. So I know this is going to have us up here at 2 for our y-intercept, but it's also going to move us to the left, right? So I'm going to draw that just like so. Okay, you should be able to put these together in any way. So again, let's do one last one. Let's say I have 1/2 x squared minus 2. So this will have us moving down, and this will have us getting wider. It'll be compressed towards the x-axis. So I move down, and I'm also getting wider. And that's all I have for you.